students. Myself, Shivi and Dr. Kiran Yadav. In this session, I will discuss about projectile motion. So let's start our discussion. What is projectile? Projectile is any object which is projected by some means and continues to move due to its own inertia. तो बेसिकली आप जब किसी भी चीज़ को फेंकते हैं, that motion is projectile motion. In the picture you can see that there is a person who is throwing a ball. So the path of that ball or the motion of this ball is the projectile motion, and the path that the ball covers is projectile path. And a projectile motion or a projectile moves in two dimensions, therefore it will have two components. So if we can take velocity, then the velocity of the projectile will have two components, which will be horizontal and vertical. So as the motion is in two dimensions, so every physical quantity will have two components, like acceleration will have two components, velocity will have two components, and displacement will have two components. So let's discuss about the horizontal velocity component. It never changes, covers equal displacement in equal time periods. This means the initial horizontal velocity equals the final horizontal velocity. In other words, the horizontal velocity is constant. But why? Gravity does not work horizontally to increase or decrease the velocity. So in case of velocity, only the vertical velocity component will change and the horizontal velocity component remains constant. So the vertical velocity component changes due to gravity, does not cover equal displacement in equal time periods. Both the magnitude and direction change. As the projectile moves up, the magnitude decreases and its direction is upward, and as it moves down, the magnitude increases and the direction is downward. So the direction of both the components is shown in the diagram. The vertical velocity component is shown by the red arrows. Combining the components, these components produce what is called trajectory or the path, which is parabolic in nature. So in case of horizontal velocity component or the horizontal component of velocity and acceleration, the magnitude and direction both are constant, and in case of vertical component, both magnitude and direction changes. So there are some projectile which are basically horizontally launched, like when we throw a projectile from a height and we throw the projectile horizontally, not in upward direction, then that projectile is horizontally launched projectiles. So it can be defined as projectiles which have no upward trajectory and no initial vertical velocity. So here Vx will be constant and Vy will be 0. To analyze a projectile in two dimensions, we need two equations, one for the x direction and one for the y direction, and for this we use kinematics. We can write x is equals to vt or x is equals to vxt, because in x direction the x component of velocity will be vox. Remember, the velocity is constant horizontally, so that means the acceleration is 0. Clear? And we can write the other equation as y is equals to half gt square. Remember that since the projectile is launched horizontally, the initial vertical velocity is equal to 0. Now we consider an example of horizontally launched projectile. A plane is traveling with a horizontal velocity of 100 meters per second, is 500 meters above the ground. At some point, the pilot decides to drop some supplies to designated targets below. A. How long is the drop in the air? B. How far away from point where it was launched will it land? So let us see what variables are given in the question and what we need to find out. So we are given Vx, which is 100 meters per second, y is equals to 5 meter, Vy is equals to 0 meter per second, and the value of g is minus 9.8 meter per second square. And we need to find the value of t and x. So using the formula y is equals to half gt square, we can find the value of t, which comes out to be 10.1 second. And to find the value of x, we need to multiply vx with t. The value of vx is 100 and t already found by us is 10.1. So on solving this, we get the value of x equals to 1010 meter. So next, let's discuss about vertically launched projectile. So in vertically launched projectile, the projectile is like thrown upward or at some angle from the horizontal. And so at the path is shown in the diagram. There is no vertical velocity at the top of trajectory. Okay, and here also in case of horizontal components, both magnitude and direction changes. Magnitude and direction remains constant, and in case of vertical, the magnitude decreases up and increases down, and the direction also changes. So let's discuss in detail about the vertically launched projectile. Let us consider a projectile which is launched at an angle theta from the horizontal with velocity v0. The x and y components of velocity can be written as v0x is equals to v0 cos theta, v0y is equals to v0 sin theta. There are several things you must consider when doing this type of projectiles besides using components. If it begins and ends at ground level, then y displacement is 0. So y is equals to 0. So in this case, we can write the equations as x is equals to voxt, and in place of vox we can write the value v0 cos t, and the equation for y can be written as y is equals to voyt plus half ct square.